Howdy, howdy, this is Mr. Potter. In this episode, I want to go through the GUI. We've been dealing primarily with the rules of how to play 11s, the idea that we would try and take a 7 and a 4 and match them, or have a queen and a king and whatever jack we happen to find and match them up. But today I actually want to talk about how this GUI is constructed, and so I want to go through this step by step to kind of explain what's going on. And the first thing you notice is this wall of import statements up here. And these import statements help us, this is all the stuff that we have to import. A lot of people will put like java.util.star as a way to kind of import everything that you'll need. That's not necessarily a good idea. A good idea is to go ahead and just list off all the things that you know you do need, especially if you're going to be developing for a platform that has limited memory like mobile. It's always a good idea to do that. And so we've got these import statements, and I kind of want to explain exactly what we're doing with these. So the first group of statements we have up here are the java.awt, and AWT stands for the Abstract Windows Toolkit. This is what, when Java first came out, with Java 1 and Java 1.1, these were the things that were primarily used for your graphics. So these are the very basic, very elemental points of graphics. So you've got your point, which is an X and Y location. You've got a graphics, you've got dimensions, you've got font, color, and then of course you've got this toolkit, which we'll explain in a little bit more detail later. These are the very basics, and almost all graphics program has to deal with these. But then later on with Java 1.2, we got some more advanced stuff, and that's this swing class here. And the swing class gives us what we call lightweight elements. These lightweight elements look the same no matter what operating system we're at. So if we're using Linux, or if we're using a Mac, or like I'm doing here using Windows, a JFrame looks like a JFrame, and it has a consistent look. And so I want to explain what each of these parts are. So the frame itself is this box here, this box that everything is held in. And the objects inside of the frame are composed of panels. So I've got one big panel here, and we're going to be adding things to this panel. A J button is these buttons here that we're dealing with, so our replace button and our restart button. The J label are these labels here, like the 43 undealt cards and the you've won 0 out of 1 games. But it's also the you win and you lose labels, which are currently hidden. And then we have the image icon, which are all of these pictures of cards that we've got. So the JavaX swing classes are actually the classes that we visualize. There's a couple of other things we have up here, the event classes. So I want to talk a little bit about those. And there's two main types of events that we're using here. We have our actions, and then we have our mice events. So our action listeners depend with the buttons. So whenever I click on the replace button, or whenever I click on the restart button, that's triggering these action listeners. But whenever I click on a card, whenever I click on it to select it or click to unselect it, that's actually happening with these mouse listeners, because these aren't buttons, so action's not happening. I actually need to physically trace when something happens with the mouse at those locations. And then we've got a couple of other things down here. For simplicity's sake, we're using URLs, which stand for Uniform Resource Locators. We're using these for the file names. And these come from the .NET, because I can use these for files, but I can also use these for HTTP references if I'm loading web pages. I can also use these for any type of address, either a local address or a foreign internet address. And then we've got the list and the array list, which we've been dealing with throughout our course. So that's kind of a brief explanation of what's going on with these import statements. And so the next thing I want to do is I want to kind of talk about these constants up here, because these constants directly deal with the graphics that we have. And so I've got default height and width, and of course the height of my frame is 302 pixels. The width of my frame, how wide this box is 800. And each of my cards has a default set. Each one of these has a width of 73 and a height of 97. And I've got this layout top and layout left. And basically what I'm saying is, from this point right underneath my menu bar, this height is 30 and this width is 30. And I can talk about the width and height increment, the difference between each side of the card from here to here. This width is 100 pixels, which I've got right here. And the difference in height from this part of the card to this part of the card is 125 pixels. And then I've got other values here. These are my button top, button left, and my button height increment. This button is 30 away from the top and 570 away from the left side, and the distance between the top of this button and the top of this button is 50. And then I've got the same things for the labels down here. So I've got a label here which is 160 down from the top and 540 away from this side. And the difference between the top of this label and the top of this bottom label is 35. So all of these private static final ints basically help me get locations for where the objects on my GUI are. So now that we've had a chance to talk about that, let's scroll down and talk about our instance variables, because we do have some instance variables here. Let's scroll down a bit. So I've got my board. This is the board that we were talking about, and remember that this board is actually this board abstract class that we're talking about. So this could be an 11s board or it could be a 13s board, because we had our board class and we had two subclasses that we developed. We developed the 11s board, and we also developed, or we inspected the 13s board. And both of these are subclasses, and if we decided that we wanted to make some other boards out of this, we certainly would have the opportunity to do so. And then we have the graphical component. So this is our panel that we're adding everything to, our two buttons that we create, the replace button and the restart button, and we'll talk about how to put those things on. We have four labels. We have status message, we have our totals message, we have our win and loss message, and then we have an array of labels, and these are the labels that actually display the cards. And keep in mind, if I'm dealing with the 11s game, then we're going to have 9 in there, but the 13s deals with 10, and those all deal with the accessor from board that we had. And then each of my card coordinates have a location that we had offset from the final static ints that we talked about up here. And then we keep track of the selections, because as we go through, each of our cards are either going to be selected or they're not going to be selected. So we're going to have an array of selections, which again would be the same size as the array of J labels that we've got, and we're also keeping track of the number of wins and the number of games that we play. So these are our instance variables that help our GUI to both play the game in a visual way, as well as to keep track of the state of the game as we go. So the next thing we've got here is our constructor. So I'm going to scroll down here to our constructor. Remember, the purpose of a constructor is to fill out those instance variables, and that's essentially what we're doing. So over here, I've got my board is equal to the game board, which is a parameter that's passed to the constructor. And the very first time that I play this game, I have no wins and no games played. But then it's a little bit more complicated here. Remember that our graphics is supposed to put cards in a row. So X is layout left, Y is layout top. So that's going to be this first spot, which is 30 and 30. And this is where our first card's going to be. And then what we're doing is we're setting up a loop for whatever the length of this card coordinates array is. And we're creating a new point, and we're incrementing by the width. Remember, this width was 100. So that's going to give us our new card coordinate. Then we go 100 over, and that's going to give us our new card coordinate. But as soon as we hit this situation where I mod 5 equals 4, remember, this is card 0, this is card 1, this is card 2, this is going to be card 3, this is going to be card 4. As soon as this remainder is 4, we actually drop down to the next level. We increase our height increment, and we reset our width back to this spot. So card 5 shows up here, card 6 shows up here, 7, and 8. And that's how we get all 9 cards. And if we happen to be playing our version of the 13s game, then that 9 gets here. And so what we're doing is we're setting up these coordinates so that later on we can put our cards at these positions. And then we go ahead and set up our selected array as a new boolean of board.size. Remember that board.size tells us how many spots we're dealing with, either 9 or 10, based on whether we're playing 11s or 13s. And then we've got a couple of other things here. I've got init display, and this needs to be called the first time that a frame is created. And we're actually going to talk more about this after AP. We're going to be doing a unit on GUIs to kind of explain what's going on. We also have this set default close operation, because when I have this and let me get my GUI back up. But whenever I click on the X button, In Java, that doesn't always close the program. What it does instead is it just hides it so that we can close it after we've taken care of our state variables, after we've saved files, and so forth. But we've actually got it just to exit on close. And then we do this repaint. And this repaint method actually helps us to redraw everything that's been done. And we're going to physically write this repaint method, or we're going to see this repaint method drawn down below. Now you'll notice we've got this display game. The only thing that's really of essence that we need to talk about right now is this idea of set visible true. The very first thing that we're going to be doing when we display the game is to make this frame visible. Everything else here is kind of a little bit above our level at this point. We're going to talk a little bit more about this during our GUI level. So let's go ahead and scroll up a bit. So this is our repaint method. And of course, the idea of the repaint method is that we're going to have to show our cards and show our messages. So what we're going to do is we're going to actually get the file names, and we'll talk about how to get the file names in just a little bit. There's a clever way to get the file names based on the card that we're dealing with. And we're going to store that in a URL, that uniform resource location. And if it's null, then we're going to load the card back. If it's not null, then we're going to load that particular image. Hopefully, of course, that file is going to be there. If it's not there, then this is the card image not found. We're going to throw an exception. And what we're doing here is we're setting up the image icons that we discussed, and we're going to make sure each of them are visible. We've got some labels, so we're going to set the text of our labels, and we're also going to set the visibility property of it. We're going to set the text based on how many cards we have left, as well as how many wins and how many games we've played. This pack statement is something that's essential whenever we're doing a GUI, is to make sure that everything's in its proper location, make sure that everything fits together, because even though we have an idea of what coordinates we want, sometimes we're trying to stuff too much onto a GUI and we have to take care of that. The pack takes care of that for us. And then the panel.repaint, this actually essentially calls on the super repaint method that actually paints it for us. And we'll talk more about that when we go through our GUI unit. And then we have our Initialize Panel, which essentially paints it for the very first time, creates a new panel, and adds a method to allow it to be painted. Alright, so then this is what we're doing here. After we've painted our thing for the first time, we have to get our class name, which of course is either going to be 11s or 13s, and we're going to be adding this to the title bar, because our title bar is going to tell us which game we're playing. That's essentially being done right here. We're going to take care of the rows and heights and stuff like that, so these are telling us where our locations are going to be. That's horrible outlining. So what we're doing is we're calculating if I have 9 cards or if I have 10 cards, how are we going to set this up? Keep in mind that my gameplay could have a different number of cards. If you're playing the traditional solitaire has 7 cards in it. So we would have something like that. If I'm playing something like Free Cell, then I have 8 cards, but those 8 cards are separated into a group of 4 and 4. And so what we're doing here is we're trying to create a GUI that can handle any number of cards. Maybe there's another card game where I want to match up all 4 of something, so I'd want to have more than 2 rows of cards. This is going to take care of that, making sure that we have 5 cards per row. So if I have more than 2 cards, I can continue to add cards to this. Then down here, we're actually setting up how to display the cards. So we're setting up a J label of a particular size. We actually have 9 cards in our 11s game, so we're creating 9 J labels in this array of display cards. And for each of these, we're adding the card to it. We're having the card add itself to the panel. We're setting the coordinates, which are the X and Y coordinates, with each card width and card height, which we set up at the top. That was that 73 and 97 that we dealt with. And this is something else that's interesting. We're adding a mouse listener because we want the cards to be clickable. Normally, panels, images, things like that aren't clickable. And so where the action listener doesn't take care of that for us. We need to take care of that, and so we need to explicitly add a mouse listener to it. And then the other thing we're going to do is set our selections, which is our array of booleans, we're setting it to false. And then after that, we're dealing with our buttons. So let me clean this up and scroll down a bit. Remember that we had two buttons in our display. We have our replace button and we have our restart button. For each of these, we're going to make sure it gets added to the panel. So I see that happening in both of these. I set the text on it, so make sure that the words I see on it are replace and restart. And I set bounds, so I'm setting the location. So this is the top left corner, the top right corner. This is going to be the bottom left and bottom right. Actually, excuse me, that's width and height. So this is going to be 100 wide and 30 pixels tall, 100 wide and 30 pixels tall. And because these are buttons, there's a certain behavior that's expected, and the action listener actually takes care of that. So each of these buttons adds themselves to the action listener and makes sure that it takes care of it. We have several labels that we've got. We've got our status label, which tells us how many undealt cards we have, and we're setting up the size. It's a width of 250 and a height of 30. And then we have these two other labels down here, our win labels and our loss labels. And what's important to note is that these start off invisible. We're setting the visible part to false here and here. But for each of these, we can set stuff out explicitly. We're setting the font, and this font is a sans serif font, because I don't know if I'm going to be running in a Windows environment and I'm going to have access to the Arial font, or if I'm going to be in a Mac environment and I'm going to have access to Helvetica font. But all fonts have a font family that they belong to, and both of those belong to the sans serif. So that's the difference between having a letter like this and having a letter with the little marks on the top and bottom. So this is a serif, and these are all going to be our sans serif. And although these are easier to read, these kind of have a cleaner look to them, and that's what we're looking for here. Both of these are going to be bold, and our lose message is going to be red, our win message is going to be green, just because that's the way our societies have been brought up. And we're making them invisible. We set the visible aspect to false. We're only going to make them visible if we physically lose the game or physically win the game. And we'll talk about that a little bit later in our discussion tonight. So scrolling down, we had our status message, and then we also had our totals, which tells us how many games we've won and how many games we've lost. As we did before, we add it to the panel, and as we did before, we set the width and the height. And as you remember when we did our playthrough of the game, it is possible to lose at the very beginning, because just none of the cards happen to work out. So if we lose at the very beginning, then we call on this signal loss, which we'll see a little bit down below. We've got our pack, get content pane and get root pane. These are things that we're going to talk about a little bit more when we go through our GUI unit. And then we've got our set visible to true to make sure the entire panel is visible, because otherwise we're just going to see a gray box with nothing on it. Alright, so the next thing we have is our signal error message. And this is important because there are some things that are very difficult to do that are very system dependent. Like the way I would do something on a Mac, and the way I do something in Linux, and the way I do something in Windows are very different code-wise. And so what happens is that the Abstract Windows toolkit has something called a toolkit object that we can instantiate. We can tell the panel to get the toolkit for this and then tell our toolkit to specifically beep. Now the process of getting a beep is different for each operating system, but we don't have to worry about that. We just use this toolkit and say, hey, do a beep for us. And the computer does it very well. Alright, so the next thing we're at is this image file name. And I mentioned this clever way. I want to go to the file system down here, and I do want to talk about what the files are. So I'm going to go back to a chapter that I know, like chapter 9, which has cards in it. And if I look at these files, you'll notice several things. You'll notice that the 2 clubs, the 3 clubs, the 2 diamonds, 2 hearts, and so forth, it's basically the rank followed by the soot. And if I scroll down, I can see this here. I've got ace hearts and jack diamonds and jack spades and king hearts, and I've got jokers as well, which we don't use in our card game, but maybe you do. Here is this back. So in other words, if my card has a null value, then I want to choose this back of a card. Something else you may notice is that I've got ace clubs and I've got ace clubs S, and whenever I have this S as the last character, it means that it's shaded. And it's not actually just shaded, it's inverted. You notice that the reds change to this cyan color. And when we talked about the picture lab, we talked about how each color, each pixel has a red, green, and blue component. If I have something that's red, like this diamond in the 10 of diamonds, then that has a full intensity red 255 and no blue and no green. But over here, if I just add blue and green, I get this cyan color, and this is the color with no red in it. So these are actual negatives of each other. And this is what happens when I select a card. So I'm going to go ahead and pop back to my code. So what happens here is I'm going to physically construct the card based on the card name. Now, if it's null, then I want to do that back1.gif that we talked about. But if it's not null, then I'm going to go down here and I'm going to physically build it based off the rank and the soot. So if I have the 2 of hearts, then my file name is going to be 2 hearts.gif. And then if I've got it selected, remember this is our Boolean true or false, then it's going to physically add a capital letter S, making sure that I've got the shifted version of these cards. Because remember that each of these have a selected and a deselected version. So going back, and then of course we concatenate it with this .gif here. So this allows us to create the file based off of the rank and suit of the file. It's a very clean and clever way to do this. And so up above when we were doing our back above when we were doing our URL, our uniform resource locator to get the file name, which was up here. This is where we're actually getting the file name at a particular location and loading that image, the spot right here. So really interesting stuff there. All right, continuing with our analysis of the GUI, this is where we're dealing with our action performed. Keep in mind that there's basically 2 actions that can happen here. The actions deal with the buttons. So when I'm talking about the buttons, I'm talking about there's 2 buttons that we have. We have the replace button and we had the restart button. And so we're going to take care of those 2 cases. Our E is the event that called the method, and I can get the source and make sure that it's the replace button or if it's the restart button. And if it's the replace button, then I want to go through and I want to replace those cards as long as it's a legal selection. This is legal actually comes from my board class, and we had to overwrite that method in 11s, and we saw how it was overwritten in 13s. And then we're going to call upon the replace selected cards method using that selection of cards. And then we can check to see if the board is empty, if we've won. If there's not another play that's possible, we lose. So this is going through all the steps that happen if we click that replace button. So it's going to go through and see which things are selected using the selection array. And so if it's true, it's going to add it to that list. It's going to see if it's a legal selection, and if it's not a legal selection, we're going to let them know it's bad. And then we're going to deselect everything. And after we've deselected everything, we're going to go through and check it in our board class. Now for our restart method, the restart method's a little different. What we're going to do is just go through and reshuffle the deck and redraw all the cards. So we do the board.newGame, which shuffles the deck for us. We set the default button because after we've restarted it, the next thing we're going to want to do is replace something. We're probably only restarting if we've won or if we've lost the game, so we're setting both of those messages to false just in case. And then we're checking because we saw several times when we restarted that there wasn't a possible play, and so we instantly lose the game, and so we're taking care of that here. And then, of course, if anything bad happens, if anything else calls on that, that's something that's unintended, and we signal that an error happened. Signaling an error just basically gives us that beep that we were talking about. All right, so if I win the game, which is going to be called from this replace method that we just talked about, then we're going to say, okay, the restart button's probably the next button they're going to select. We're going to set our win message to true, and we're going to increment both the wins and games that we've experienced. But if we've lost the game, If we hit a loss scenario, then we're going to again set the restart button as our primary button, but then we're going to set our loss message to true, and we're only going to increment the total games. We're not going to increment the wins because we just didn't win. So this takes care of all the action listener stuff, and the action listener deals with buttons. The mouse listener deals with the images that we've drawn, and so I want to deal with that here. Now I'm implementing the mouse listener interface, and remember that when we're implementing an interface we have to write the methods that the interface is expecting, and this interface actually expects 5 methods to be written. It expects to know what happens when a mouse enters or leaves the frame, because if I move the mouse in or I move the mouse out of a frame, that's going to change some state. I also have something called pressed, or released, as well as clicked, because I can push a mouse button down and that's going to do something, and if I let the mouse button up, that's going to do something, and then if I click, which is a press and release together, that's going to do something. But I really only care about this, and so these 4 methods, as we'll see below, have just empty code in them. I have to have the method. My method does nothing. So here's our Mouseclicked method. So if I've clicked, I'm going to have some event, some location, and what I can do is find out, okay, did I click on one of those panels, one of those display cards? And is that card not null? Because if the card's null, really there's no purpose in clicking it. But if I've clicked it, then I want to take the selections, remember this is our array of booleans, and change its value. So I want to talk about what's actually happening here. So let me jump over to our graphics. So if I take this and I click on the 10, clicking on the 10 selects it. So it was false, now it's true. And if I click it again, it was true, now it's false. It essentially takes its Boolean truth value and flips it. So true becomes false, false becomes true. And then I repaint, because I've changed the selection state, I need to reload the new image. And so once I've reloaded that new image, then I'm good and I return. If I make it through here and nothing was there, then we're going to call on that signal error that we had. And as I mentioned, we are supposed to have these other methods. If I scroll down to see these other methods, you'll notice that there's just nothing but empty code here. So we've done this nice little tour of what actually goes on in the GUI, because the GUI is the interface between the human and the machine. The board class that we dealt with deals primarily with how to play the game, but the GUI is the steps that a human actually goes through to physically play the game. And it's different from just understanding the rules of the game or why things happen. And understanding how this GUI works is really going to help us to understand how we interact with the game and how the game responds to our interactions. And as I mentioned, after AP we're going to go through a whole series of understanding how to build a GUI from scratch, because some computer languages have a drag and drop method of building GUIs. Some computer languages have forms that you can deal with, or what you see is what you get, a WYSIWYG editor. Java doesn't necessarily have that, but it's often just better to understand what's going on in the code so that we can precisely set up panels at particular locations. Some of the other things that we've glossed over is the idea of a layout. Here we're saying our layout is nothing because we're physically listing the coordinates that our cards and buttons are at. But there are certain layouts, like a grid layout or a border layout, where we can physically place things on the north, south, east, west, or in a 3x5 array of things. And those are tools that we have, those are tools that Java gives us to build a GUI to look a certain way. In our case here, this GUI is helping us to understand how the author's intending this to look. And so it's a wonderful tool to look at. I certainly hope that this tour has given you a better understanding of what the GUI works at. Our last video that we're going to talk about is going to deal with how to test these board classes that we've written and how to run simulations on them. Because we certainly can't sit and play 100 games or 1,000 games, but we can program the computer to do so, and that's what we're going to talk about next time. So once again, this is Mr. Potter. Thank you for watching. Have a great day.